All right, in this video, we're going to do several applied problems, and they're all going to involve using a quadratic function. And what we're going to wind up doing on all of them really is finding the vertex. So the main thing we need before we start these is what we did in the last video. We need the formula that tells us that the x-coordinate of the vertex of a parabola is given by xv equals minus b over 2a. So let's look at solving some problems with this. The height in meters of a ball thrown in the air is given by this function. Find the maximum height of the ball. All right, so if you think about what this says, a ball is thrown up in the air and its height is given by this quadratic function. If you think about it, that makes pretty good sense because a quadratic function, a in this case, is negative. So that means it's a parabola that's going to open downward. So you can think of this as time goes on, the ball is going to start here, and then it's going to go up, and then it's going to come down. Now, the ball might be flying in an arc, or the ball might be thrown straight up and back down. But however it's done, this right here, remember, tells you the height. So let's work this out. Actually, before I delete that, the maximum height is going to be the y-coordinate of this vertex up here. So let's find that. All right, xv. In this case, maybe I should call it tv, but I'm not. I'm going to still call it x. It's minus b over 2a. B in this case, these are out of order over here, but don't let that mess you up. B in this case is 20, and A in this case is negative 4.9. So let's see. 20 divided by 2 divided by 4.9. Now, I'm putting that in my calculator like this. Not sure how well you can see that. Let me turn this on. For order of operations, notice what I'm doing. I'm doing 20 divided by 2 divided by 4.9. That's this actually gives me a fraction. It's 11 over 49. I'm sorry, no, it's 100 over 49. Which is approximately 2.0408. And I'll just leave it there. But now that's, I am going to go back and change this to a t. That's when the ball is at its maximum height, after 2.04 seconds. So the max height is going to be h of that number. So it's going to be 20 times 100 over 49 minus 4.9 times 100 over 49. Now, the reason I'm using the fraction is because the fraction is exact. So I'm going to put that into my calculator now. Let's see, 20 times 100 over 49 minus 4.9 times 100 over 49 squared plus 2. That gives me a final answer of 1,098 over 49. Or 22.408. And let's see, that would be in meters. I was about to write feet. So that's the maximum height of the ball. All right, let's look at a couple more problems. The two additional problems I want to do are both fence problems. On this problem, a farmer has 300 feet of barbed wire and he wants to enclose an area next to a long building, which is what I've got drawn here. This is the building over here, and this is the pen that he wants to enclose. I'll make it green. Hopefully it's grass in the pen there. Okay, we've got to figure out what's the maximum area that he can enclose. Now, before we figure this out, let's model it a little bit, or look at a couple of possibilities. One bad thing he could do would be to run his fence out like this, where it's roughly 150 feet over here, and roughly 150 feet over here, and pretty much zero there. That would be a terrible way to do it because there's no area inside of that. It's just it's basically two pieces of fence just running right next to each other with no room in between. The other bad way to do it would be to go to the other extreme. I'm going to draw a separate drawing here. Let's say this is the building. You could run the fence out like an inch here, then run it almost 300 feet, and then back in there. And again, that's a really long, narrow fence, or fenced-in area with very small area. So, of course, the best way to do it is going to be somewhere in the middle, which is probably roughly what I've got drawn, where you come out a good ways, then you go down a good ways, and then back, and you get a pretty big area in there. So what we need to do is give this some variables and work out what it should be. So let's let x be that length of fence. And then this length down here, since it's a rectangle, that's going to be the same. Now he's got 300 feet total. So that means that this other line here, this bit of fence is going to be 300 feet minus 2x feet. So that's sort of a general way to write this out. So the area of this thing is going to be length times width, which in this case is 300 minus 2x times x. So that right there is going to give you the area of the pen for any value of x that you plug in. So now we could tell you what, let's graph it and then let's actually work out the answer. So we've got 300, let's see, a of x equals 300 x minus 2x squared. All right, and it looks like we don't even have a parabola, but it's because I got to zoom out to see it. This parabola is huge. I'm going to adjust my size here. Let's see. How far up does this thing go? Up above 10,000 it looks like. So let's make x go. Let's make y go from say 0 to 15,000, and let's make x go from 0 to let's say 300. 300 is a good thing to stop at because we know that's the most fence we could use. All right, so if you look at this, this parabola tells us the area of the fence, the area of the fence in pen. So any point that I pick, like this point right here, I can't quite get it on 20. Let me zoom in. Yeah, okay, if we made x 20 feet, then the area would be 5,200 square feet. If we made x be 35 feet, then the area in there would be 8,050 feet. So what we really want to do is come up here and get the maximum. So the best we could possibly do would be to make the area 75, or I'm sorry, make x be 75 and the area be 11,250. So really all we're doing is finding the vertex of this parabola. But let's do it without Desmos. This is a good way to look at it and see what's going on. But let's do it by hand to actually find the value. All right, so we've got that. Our x for the vertex is going to be minus b over 2a. Let's see, b in this case is 300. A in this case is negative 2. So I've got 300 over 4. I'm just canceling those negatives. 300 divided by 4 is 75. So 75 feet is going to be the x that maximizes things. And I could take that 75 and plug it back into a of x. Let's see, 300 times 75 minus 2 times 75 squared gives me 11,250. So that's the maximum area that could be enclosed. That's in square feet. That's one way you can do it. The other thing you could do is, once you've got that x is 75, we could say, well, x is 75. Let's call that the width. The length then, the length is this up here, this 300 minus 2x. So that's 300 minus 150, so that's 150. And so the max area is going to be 75 times 150, just length times width, which is still 11,250. All right. Let's do one more problem. Okay, so we've got another farmer, and this time he's got some fencing, and he wants to fence in 3 pens. Let's make them nice and green. The question is, how does he do this to maximize area? All right, in this case, he's got 900 feet of fence. So here's what we want to do. We've got these 2 pieces of fence that are one length, and then we've got these 4 pieces that are this other length. So these 4, I'm going to let each one of those be x. And this length over here, and the length on the top, both of those are going to be 900 minus 4x over 2. Let's see, I can divide that out. That's going to be 450 minus 2x. All right. Where did that 900 minus 4x over 2 come from? Well, think of it this way. You use up, of your 900 feet, you use x feet here, x feet here, x feet here, x feet here. So that's 4x feet that we have to subtract off of the 900. This is what we have left. The reason you divide by 2 is because you use half of that on the bottom and half of it on the top. All right, so the area function here is going to be 450 minus 2x times x, or 450 minus 450x minus 2x squared. Now we could go through and graph it all again, but there's no need to do that. Finding the maximum, we just need to do x is minus b over 2a. So that's going to be minus 450 over 2 times negative 2. So that's 450 over 4. What's that, 112.5. Yeah, 112.5. So that's going to be my, I'm circling that, but it's not my answer. It's one of the things I need for my answer. That's my x, so that's my width. The length of this thing is going to be 900 minus 4 times 112.5, all that over 2. It's 225. And so the max area is going to be 225 times 112.5, which is 25,312.5 square feet.